alaikum. My name is Yasir Jamal and I'm joined by Muhammad Abir Asim and Yahya Ansari will be editing the video and Abir Asim will be explaining the slides and I will be explaining the code and the implementation of Secant method. So let's start. Abir, can you please continue with the slides?
Assalamu alaikum everyone. Today our topic is second method in computer sciences. First of all, I will be giving a brief introduction about what is second method in computer sciences. The second method is a basically numerical technique or a mathematical technique used to find the roots of a non-linear equation. It is basically used in the computer sciences for optimization problems and simulating dynamic systems. And now moving on to the next slide. Now we will talk about that how second method works. Second method have basically two subcategories. Those are curve fitting and methods. First of all, I'll be describing the curve fitting. The curve fitting in the second method is basically used to find the roots of nonlinear equations, including finding of intersection in their curves. And about the method is the second method is used to the second method uses linear interpolation to approximate the root of non-linear functions through the intersection of two approximating lines. Now moving towards the next slide. Now I'll talk about the advantages of second method. Second method has basically three main advantages. Those are faster convergence, no derivation required, and multiple starting points. First of all, describing the faster convergence, those are the second method is faster than the bisection method when it comes to the convergence, making it a great choice for functions with multiple roots. Now coming towards the no derivation, those are the second method does not require the evaluation of a derivative, making it a great choice for a function that are difficult to differentiate. Now the third advantage of second method, and it's really important, that is that second method is can handle multiple starting points for the approximate lines, leading the higher chances of finding the roots. Now moving towards the next slide. Now we have the limitations of the second method. Limitations of second method also have three main points or the three main sections. Those are no guarantee to find the roots. Uh, uh, the second method can fail to converge when choosing an appropriate starting point or when the function has no root. Now, the second point that is sensitive to initial conditions, that is, the second method may converge slowly or not at all if the initial approximation is not close enough to a root. And the method is that third limitation is that it can be computationally expensive. The second method may be slower compared to the other methods such as Newton, which uses the first derivative to approximate the roots. Now moving towards the next slide. The, the next slide is about the application of the second method in computer sciences. Those are optimization problems, solving nonlinear equations, and numerical analysis. Now, first of all I'll talk about the optimization problems. The second method can be used to optimize the constrained and unconstrained functions if optimization. Now, solving the nonlinear equation. The second method is used in simulating dynamic systems that contain nonlinear relationships, such as predicting the stock prices movement, and numerical analysis contains the second method can be used for numerical derivatives and integrals. Now, moving towards the next slide, that is the comparison of second method with other numerical methods. Comparing the second method with the other numerical method, we have bisection method and Newton-Raphson method. Bisection method is basically slower in convergence and only applicable for function with one root. Uh, Therefore, the Newton-Raphson method is faster in convergence and requires the evaluation of a derivative. Now, moving towards the next slide, because we'll conclude our presentation with telling the practical and future of the second method. The practical of the second method. is the practical of the second method and efficient method for finding the roots of nonlinear equations and optimization problems in the field of computer sciences. Now we got the future of the second method, that is, as the technological advancement continues, the second method is set to play an even bigger role in solving complex problems in computer sciences and beyond. Now Yasser will tell you about second method, and he will define the code that we have generated.
Okay, thank you so much, Abir. That was it for the slides. That was the part of Abir explaining the slides. Now we will come to the code. So this is the code for the basic implementation of secant method. So when we start the secant method code, first we will define a method, secant method, and we will put in the parameters which acts as the inputs. First we have function, then we have x naught, x1, then the tolerance, and then the max iterations, like it will tell, like it will iterate how many times can the code can iterate this. So right here we have set it to 100, so it can go up to 100 maximum iterations. Then we will apply a for loop in this, and then we will generate two variables, the one we had earlier. We will write fx naught and equals to function x naught, and fx1 equals to function fx1 function x1. And then we'll write if fx1 is less than tolerance, we will return our x1 value. And then we will apply the try condition, where we will write the slopes formula, and then we will raise an error, the zero division error. So basically, second argument to a division or modulo operation, if it's zero, then it will generate a zero division error. Otherwise, it will return none. And then if the absolute, what's it called? If the absolute x2 minus x1 is less than tolerance, it will return x2. So let's say if function of x1 is minus, so first we have written the slope formula, right? So if the x1 is minus fx1 divided by slope, we will get the x2. And then if x2 is minus x1, because first here we have written function of x1 is less than tolerance. If it is less than tolerance, then we'll get returned x1. And here if x2 minus x1 is less than tolerance, then we will get the x2. So we have x naught, x1, and we will equal them to x1 and x2. So x naught is equal to x1, and x1 will become equal to x2. So basically this is going forward, the numbers are changing with every iteration. So let's say in the third iteration our x1 will be x2, and then our x2 will be x3, and then in the fourth iteration our x2 will be x3, and then x3 will be x4. So that was the main logic for the actual formula of the secant method. Now we will come to our own implementation of the code. Here we have defined a method called print header. This will basically just print the secant method solver, which we have written just for the show. And after that we defined a get float input. It will basically prompt the user to write an actual float input. And then we applied a while loop in it, and we applied the try condition, that value equals to float input prompt return value. And then if we will raise an value error, that if the value is not invalid, it will raise an error, and it will tell the user that the value is invalid, and please enter a valid number. So we cannot type any invalid number, we have to type the valid numbers. Then we define main. In the main we call the print header function, which will call this whole function we have written. And then we will define the target function. We define the target function, and the target function is basically the formula that we were given, the equation that we had to take the root of. We will write that in the function part. And then we have to print initial guesses, and then initial underscore guess underscore 1 is our variable for the first guess, and then initial underscore guess underscore 2 is our a variable for the second guess. And then we wrote the precision 1e minus e. This basically defines how accurate our answer will be. And then we wrote a variable called root, and in that root we wrote the secant method, and then we put in all the, what's it called, the parameters we had written in the secant method. We will write these in the parameters. And then we will print and then we'll write the if else condition, where if root is not none, then it will print the root of the function is approximately, and it will tell the root. else it will print the secant method did not converge, just in case if the program cannot find the root of the target function we have. And then after that, that's basically the main part of the program. This is just and then in the end it will just print. This program is made by Tech Tribe Talks, developed by Yaya Yasser Nabi, and then visit our channel Tech Tribe Talks. So I'll run it just to show you guys that it works. So first, as soon as we run it, this comes. This is our print header, which I showed you right here. Define print header. So we call print header, and then it will ask us enter initial guesses, and then it will ask us for the first guess. And now this is the get float input prompt. When we wrote this, it will ask us our first guess. So we have to write something in float. If we do not, then it will ask us for invalid. It will tell us that the value is it will give us an value error, and it will tell us that the input we have written is invalid. So our first guess, let's say we write 4, and then it will ask us for the second guess. Let's say we write 8. So it will tell us the root of the function is approximately 2.236068. And basically secant method just tells us let's say secant method, we're doing a question from a secant method. We'll get an equation of some sort, and here we have the equation. In this case we have x squared minus 5. This is the equation we have in this program, and we'll get the equation like this. And basically what we have to do is we have to find the actual root of the equation, and once we find the root, that's basically all what secant method does. And this is secant method as a program in Python. So that was it for the code, and that was it for the slides. Thank you so much, Abir. And
Thank you so much.
with this I'll just end the video. I hope you guys understood what secant method is, and I hope you understood the implementation of secant method in programming as well. Thank you for watching our video, and take care. Allah Hafiz, and hope you guys stay safe. If you really enjoyed the video, please like and subscribe and comment. And yeah, that's it. Thank you so much, guys. Allah Hafiz.